Assalamu alaikum student. Hope you all fine. Today we are going to discuss the topic that is the Maxwell equation. What is the Maxwell equation? Today we discuss about it. Maxwell equation is basically contain the four equation. First equation that is give the Gauss law. What is the Gauss law? Says that the charges create the electric field. So here we write about the Gauss law. Gauss law says that the charges create electric field. So here we write about it. Charges create electric field. What is the equation of the Gauss law? Equation of the Gauss law is that is the delta dot E is equal to rho over epsilon naught. That is the equation that gives the Gauss law, that the charges always create the electric field. Now we write about the Gauss law for magnetism. So here we write about the second Maxwell equation that gives also the Gauss law for magnetism. Gauss law for magnetism says that no single magnetic pole exists. So here we write that no single magnetic pole exists in magnet. They always exist the two poles. So Gauss law says that no single magnetic pole exists. So here we write that del dot B is equal to 0. Third Maxwell equation that gives us the about the Faraday law. What is the Faraday law? Faraday law says that the changing magnetic field always create the electric field. So here we write that about the Faraday law. Faraday law changing magnetic field create the electric field. Changing, that is give the Faraday law, that is if we change the magnetic field it always create the electric field. Changing magnetic field creates electric field. So here we write about it, that is the del cross E is equal to minus curl B over curl T. So here we write that curl cross E is equal to minus curl B over curl T. Now we last write the equation that give us the Ampere-Maxwell law. And Maxwell is basically change the Ampere equation, that is not give us the idea about the displacement current. So it write by Maxwell. Ampere equation is write by Maxwell. So this equation name is Ampere Maxwell equation. Ampere Maxwell लॉ भी कह सकते हैं, एम्पियर मैक्सवेल इक्वेशन भी कह सकते हैं, that tell us the static current or changing electric field create the magnetic field. Faraday law says that when we change the magnetic field, it always create the electric field. So Maxwell also explained that when we change the electric field, it create the magnetic field. So here we write that. Nice, ma'am. Raja Sharma. Welcome to my class. Thank you so much for your comment. Class 12. Yes जी class 12 है. Ampere Maxwell law, that is the current or changing electric field creates magnetic field. Now we write about it equation. What is the equation of the Ampere Maxwell? That is the del cross B is equal to del cross B is equal to mu naught I plus mu naught epsilon naught curl E over curl T. That is the fourth Maxwell equation that give us. First is the about the Gauss law, second is about the Gauss law for magnetism, third is the Faraday law, and fourth is the Ampere Maxwell law. Now we discuss about in detail what is the Maxwell equation, how we discover it. So first we discuss that is the about the capacitor. In capacitor, what problem discussed the Maxwell? A capacitor, we know that is block DC current because after charging no electron move across the gap. So it always block the DC current. But with AC current something strange happen. Current seem to be flow continuously. It does not stop. So here is explained the Maxwell equation how the current is continuously flow. So here we write about it that the capacitor block DC current, DC current because after charging across the gap. That is, we know about the capacitor that is always block the DC current because after charging the capacitor no more current flow into the capacitor. So but when we apply the current, but with AC current something strange happen. current seem to flow continuously. Current seem to flow continuously. So now we discover it how the current is flow continuously in the capacitor. It well explained with the Maxwell equation. So Maxwell explained it with the displacement current, how the current is continuously flow if there is no if there is insulation is present between the capacitor plate gaps. So here we write about it. Displacement current. First we explain the Maxwell. What answer the Maxwell of the question, that is how can current flow if there is insulation gap between the plates. That answer is given by Maxwell. Maxwell says that when we apply the AC current across the capacitor, electric field is built up between the capacitor plate that is changed with time. That is changing electric field like a current because it produces a magnetic field. This imaginary current between the capacitor plate is called the displacement current. So here we write it answer how current flow if there is no insulation gap between the plate when AC is applied, the electric field between capacitor plates, and we know that a changing electric field acts like a current. That is explain the Maxwell, that is the a changing electric field act like a current because it produces a magnetic field. Whenever the changing electric field, it always produces a magnetic field, and this magnetic field it creates the induced current. And this imaginary current that is produced in the capacitor, that is known as the displacement current. So here we write that this imaginary current between capacitor plates is called displacement current. Now we write about the formula of the displacement current, how the displacement current is produced in the capacitor plates. That is the formula that equal to capital I is equal to epsilon naught d phi over dt. That is the imaginary current flow in the capacitor plates. That imaginary current is called the displacement current. Due to displacement current is continuously flow in the capacitor plate. It does not stop. Ahad. Ahad, thank you so much for your comment. Welcome to my class. Only Ahad is present here. राजा शर्मा मुझे लगता है भाग गया है, सिर्फ आहद ही आ गया है क्लास में. Okay. Here we discuss about the Maxwell equations. Then we discuss the what is the problem in the capacitor, that is always block the DC current, but it not block the AC current, because in AC current the polarity is always changing continuously. Says that how the then the Maxwell explain the if the insulation is present between the capacitor plate, how the current flow in the capacitor. So it is explained by the displacement current. That is all we discussed. That now we move to the next topic. Next topic is that is the in the capacitor circuit. And we know that in the wire current flow due to the electron move, but in the capacitor plates current is flow due to the displacement current. Due to displacement current is continuous flow in the capacitor circuit. Then we discuss about the changing magnetic field always create the electric field, that is the Faraday law. Then in last we discuss about the Maxwell contribution. What is the Maxwell contribution in the Maxwell equation? That is all we today discuss. Now move to the second topic. Okay, here we discuss about the displacement current in circuit, and we know that in the wires, in the wires, conduction current flow due to the electron move. Conduction current flows due to electron moves. But we discuss about the capacitor plates. Current flow between the capacitor plate. Current flow between capacitor plates. In the last, we already discussed that in the capacitor plates, current is flow due to the displacement current. So here we write that the displacement current flow due to changing electric field due to changing electric field. We know in the last we discussed that the changing electric field that is always create the magnetic field, and magnetic field that is create the induced current. That induced current is called the displacement current. Both together make the current continuous. In the wire, current flow due to the electron move, but in the if we discuss about it between the capacitor plate, current is flow due to the displacement current. So both the current together, both conduction current and displacement current make current contribution, make current continuous. That is, we discuss in the capacitor circuit what happened in the capacitor circuit. In the wire, current is flow due to the conduction current, but in the capacitor plates, current is flow due to the displacement current. Both the conduction current and displacement current make the current continuously flow in the circuit. Next, we discuss about the Faraday law, how the changing magnetic field create the electric field. Oh, here we write about it. Faraday law says that if a magnetic field change with time, it induces an electric field. This is the principle of electromagnetic induction. If a magnetic field change with time, it induces an electric field that induced electric field is known as the principle of electromagnetic induction. This is the principle of electromagnetic induction. बहुत मोटा लगता है. Okay, now we discuss about the Faraday law formula. What is the Faraday law formula? That is the induced magnetic field that is equal to minus d phi, that is shows the changing of electric flux with time, that is create the induced magnetic field. If we write about it example where we use the Faraday law, we use in the generator work because a changing magnetic field induce current, so is generator work on the principle of Faraday law, that is the generator work because a changing magnetic field induce current, that is the Faraday law, that is changing magnetic field always create the electric field. Now we discuss about the Maxwell contribution, how Maxwell contribute in the Ampere law. Maxwell is basically contribute to explain the displacement current, so its name is become Ampere Maxwell equation. So here we write about it. Before Maxwell, Gauss law explained electric field. Gauss law basically explained the electric charges. Then Gauss law explained for the magnetism, said no monopole exists. And then Faraday law says that the changing magnetic field always create the electric field. So here we write that uh, before Maxwell, before Maxwell, what is the Gauss law explain? Gauss law explain. बहुत ही लाइट लिख रहे Gauss law इसको explain electric charges. Then the second, what is the Gauss law? Explain Gauss law for magnetism, said no monopole exists. Gauss law for magnetism said no monopoles exist. And then the Faraday law said the changing magnetic field create the electric field. So here we write that the Faraday law said changing magnetic field make electric field. In the last, that is the Maxwell changed the Ampere law. Ampere law said that the current make magnetic field. It does not explain the how the current flow in the capacitor plate. Ampere law said current make magnetic field, but Ampere law had a gap between these equation. A gap is this, that is it fail for capacitor. Why it is fail for capacitor, it does not explain the how the in the capacitor between the plates current is flow. That is explained by the Maxwell equation by adding the displacement Ampere law. But Ampere law had a gap. It failed for capacitor. Maxwell solved this. Maxwell solved this problem by adding a displacement current. That is, we already discussed about the displacement current. What is the displacement current? By adding displacement current into law, into Ampere's law. That is, we discuss about the Ampere Maxwell equation, how Maxwell explained the Ampere law. Ampere law, that is, does not explain the displacement current between the capacitor plate. It only said that the changing electric field create the magnetic field, but it fail in the capacitor plates. It does not explain that the how the uh, current is flow between the capacitor plate if the insulation is present between them. So Maxwell solved this problem by adding the displacement current into the Ampere law. And that is all we discuss about it.